So it's that time again, my first abstract algebra exam, which is entirely on group theory. Figuring it was high time to do another video on how I study. This one's going to be a little bit different from what I usually do, just because the format of the class is a little different. It's actually a lot different. My major roadblock is the fact that I don't have any lecture to speak of. The only thing I get in the way of explanations is if people ask questions about the homework. So if no one asks a question that was on the homework, then no explanation is given. I also have no idea if my answers are right or wrong that I put on the homework, because my homework gets graded, but only a very small portion of the homework, like maybe 2 questions out of 7 get graded, because the grader doesn't have time to go through 20 people times 7 problems twice a week. So one is I have to formulate my own notes from scratch. I don't have any lecture to pull them from like I normally would. I have to make them from scratch, and that takes a lot of time, but I don't really mind. I kind of enjoy it, and it gives me time to like look for things and spend time writing it and looking at it and organizing it just the way I like it. That will consist mostly of definitions and theorems and corollaries and stuff like that, just like facts. Maybe some brief examples, but mostly definitions and just hierarchies of things and stuff like that. And then the other portion, which I've kind of started to do, but I haven't fully fleshed out yet, will be methods for doing things, algorithms. It kind of depends on what I need to do, because determining whether or not a homomorphism exists, one, you obviously have to know the definition of it. But in order to determine if one exists, all you need is the definition. It's just one line, just a single line expression. And as long as you understand what the symbols mean and what it means to input something and use a binary operator, then you're fine. That's all you need is the definition. But that's not necessarily the case for something like an isomorphism, which you need the definition of homomorphism, but then you also have to prove for every element in the set that, or in both sets really, because it's a homomorphism from one to the other, unless it's an automorphism, in which case it maps to itself. Anyhow, you have to prove that it's one-to-one, and also that it's onto, and that's a little more rigorous. That's a proof that you have to do. And there are a couple lines to that, and there's simple ways to do that, and there's long-winded ways to do that. Obviously, I want to do the simplest for the sake of time, because I have no idea what to expect. I don't know if it's going to be like the problems I do in my small group, or if it's going to be like the homework, or if it's going to be stuff from out of the book, because my professor comes up with his own homework problems from scratch. I have no idea what to expect in that regard. So the vast majority of my time will be spent, like I said, creating notes that'll, of course, become reference, just like every other math class I've taken, that I can refer back to. And that'll be mostly definition and things. And then in addition to that, I'll have the things that require multiple steps. So determining if an isomorphism exists or if an automorphism exists. But there's really not a lot of stuff that requires a step-by-step process. The vast majority of it is definitions. As far as knowing what a group needs, what a subgroup needs, cyclic subgroups, alternating and symmetric groups. It's all definition. As long as you know the definition of something and its properties and the important aspects of it, you can usually, chop it up and figure it out, for lack of a better word. So in the process of making my notes, I'll probably reference my textbook as well as the couple other ones that I've had. The yellow one, Groups and Symmetry by Armstrong, that I reviewed. I'll refer to that one, and I'll refer to a couple other ones that I have lying around that aren't quite as good as that one. Like I've mentioned before, YouTube is kind of useless for any reasonable amount of content with regards to group theory and abstract algebra. The internet's very rough, and people use different terminology and word things very differently, and it's not as consistent as like calculus. I've seen that the content is lacking on YouTube for group theory, and I'm willing, and I think at this point I'm almost capable enough to be able to make a video or two on group theory, maybe like a group theory in 15 minutes or a group theory in 20 minutes, and just do a broad overview of the big stuff and dig into it just a little bit. If you would be at all interested in that, let me know. Hit the like button or leave a comment or whatever. That would be really enjoyable to do. I liked making the linear algebra one I did, and I intended on making more, but as usual, time got away from me, the semester got away from me, and then I moved. I mean, there's already a lot of linear algebra content, so that's, whatever. But that was a good exercise. That was good practice for doing them in the future anyhow. What I may also end up doing, since a large portion of this is just definitions and properties, I might make some flashcards. Probably not for everything, but there is a good deal of stuff. I mean, I'm dealing with 10 or 15 definitions and a bunch of theorems and corollaries and stuff that I need to know that are really useful. So I may end up doing that because there's no way I'm going to be able to remember all of them verbatim, no matter how many times I write them. So that's probably what I'll end up doing as well. Real quick, in addition to the group theory and 15-minute video idea that I just suggested, I'm also willing to do some examples from my homework and my worksheets. A lot of them are kind of interesting. I'd be happy to do those on the whiteboard like I've done with my algebraic proofs in the past. So again, just let me know. See ya.